Welcome to this episode of Seeking Proof, Finding Grace. I'm your host, Ron Campbell, and this episode is with every episode. I want to start off by reminding you of the most important truth in the entire universe. God loves you. And I want to start off this week by approaching this from the theistic perspective a little bit. And I want to talk a little bit about the galaxy and the universe that we see around us and what it is that we're looking at and why. You know, it's an interesting question. If you take a step back from a Christian perspective and you look at the galaxy around us and you say, well, if God's purpose is just to have a relationship with us, then what does he really need to do that with? What does he need to accomplish that goal? I mean, really, if you broke it down, God needs the sun and the earth, the moon, and that's really about it. We really don't need a lot of everything else around us. God could have created just the earth and the sun and called it good. But if God's goal is to develop a relationship with us, and you remember all the way back at the beginning, we approached this from the perspective of, if God's going to have a relationship with us, it doesn't work for him just to come out and blow us away with his presence. He's got to approach us in such a way that he can actually build a relationship with us, a relationship that's built on our free will to choose him, in a relationship that's built on love. But that doesn't work if he just steps up and blows us away. He's got to build something more than just earth and the sun, because from our perspective, if all we have is the earth and the sun, then you really do have an interesting question for how we got here. And it immediately points to a creator who did this. We were like the proverbial fish in the fishbowl at that point. And clearly something has happened, and we are the result of a direct divine intervention. There's no question, there's no anything else. And on the surface, we might be tempted to say, well, wait a minute, that's better, because that immediately reveals God's hand. But if you go back and watch those early episodes, we talked about why that wasn't true. If God shows up in Times Square tomorrow and calls a press conference and says, hey, I'm God, this is it, here I am, let's have a serious discussion, that didn't work out well in the Old Testament. That didn't work out any time that he tried it. So God has chosen to approach us in such a way that it opens up the door for a relationship with us based on our choice to join him in relationship. When you look at the universe around us, I want you to consider for a minute the possibility, and we're going to see this in the weeks that follow, that what God has done is he has created a universe for us in such a way that as our knowledge expands and grows, that at every step of the way it reveals his presence to us more and more and more. And we're going to talk about that in a minute. I love this quote from Hugh Ross's book, The Improbable Planet. Even with so much still to discover and learn about the way the world is and how it came to be this way, an abundance of evidence suggests an answer to the why question. We are here to seek and to find God and to use all the resources he has so painstakingly and generously provided within the amazingly stable and optimal climate epoch he established to encourage people from every ethnic and cultural group in the world to receive God's redemptive offer. God's desire to bring redemption to a vast and variegated population explains why the history of the Milky Way Galaxy, the solar system, Earth, and life looks as it does. I want you to consider that possibility for a minute as we begin this next phase of our journey. What if along the way we determined that at every step along the way, it's not the Copernican principle that we had talked about a couple of episodes ago, that everything is just random, it is what it is, hey, it could have ended up anyway, and this is just the way it ended up. You know, along the way, if the naturalistic theory is right, that from the Big Bang to Earth, nothing special happened, there were some lucky moments, there were a few lucky steps along the way, and we'll see this from quotes from Stephen Hawking down the road, a stroke of galactic luck here and there, and we just got to be where we are. If that's the case, then we would expect life to be very common, just like the Copernican principle says, and what we would expect to find from the Big Bang to Earth is nothing special. It all happened. There's easy, maybe not the right word, but there's pretty straightforward answers as to how it occurred. Nothing special to see here, and you can just move on about your business. But what if that's not the case? What if, as Dr. Ross suggests, that at every step along the way, what we see is something very special. Now, we've tried very hard to avoid this idea of God of the gaps along the way. And we're not going to go down that path. But if at each step along the way of this journey from the beginning of the galaxy, beginning of the universe to Earth, we see stacked one on top of another, situations, circumstances, and realities that are next to impossible, if not impossible. And each one of them had to happen in just the right way to get us to where we are today. Then what we see is the fingerprint of intelligence. And it's not wrong or inappropriate to say exactly that what we see is the fingerprint of intelligence. And I think that's what we're going to see in the weeks to come. So what we're going to do is we're going to take this journey from where we were. Remember, the two steps that we've taken, and it's taken us a while to get there, the cosmological argument, where did the galaxy come from? The teleological argument, looking at the complexity, the fine-tuning of the galaxy itself. But we haven't really gotten past the building blocks of the Big Bang. We started to a little bit on the last episode, but now we're going to jump into high gear, and we're going to move forward and look at all of the little steps along the way that it took. And I say all. It's not going to be all. There's so many of them we're going to have to skip past because there's just so many. But we're going to look at these steps along the way, getting to Earth before we get to life on Earth and us. Was it just a routine journey, or do we see the fingerprint of intelligence? And what I think you're going to find is the third miracle along the way. The first miracle being the creation of the galaxy, because it defies explanation outside of a third party. The second miracle being the fine-tuning of the universe, because again, it defies explanation without a third party. And what you're about to see is the third miracle along the way, which is all of the various steps that it took to get us to this little blue planet. So we're going to jump in and we're going to walk through this. And what we'll see is God's purpose in building a universe that as our intelligence grows, as our knowledge grows, as we grow as the human race, what we'll be able to find is as we peel back layer after layer, at every point we see his fingerprint. And the more we've learned in the last 100 years, the more we see his handiwork. And that's what we're going to see in the weeks to follow. So let's jump in and get started this week. Now, you remember in the previous episodes, we talked about the materials that we needed, the building blocks that we needed to get here. And this is going to be the conundrum that we've got. To get to us, you need a very specific set of tools. And we talked a lot about Fred Hoyle's discovery of what it took to get the carbon that was needed to produce us, since we are a carbon-based being. What did it take to get the carbon? And you remember, this is one of those items that we looked at that was so improbable. Fred Hoyle, an atheist at the time, said, a common sense interpretation of the facts suggests that a super intellect has monkeyed with the physics, as well as with chemistry and biology, and there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put the conclusion almost beyond question. So as Hoyle looked at this, he looked at, well, what would it have taken in the early universe to get from nothing to where we are today? And so the standard theory goes that what happened was the Big Bang produced the materials necessary that gravity brought together and produced the first generation of stars. And that first generation of stars went through their life cycle and they exploded in just the right way, and the debris that came out from them would be used to produce the next generation of stars. But in that sequencing between the first and the next generation, you picked up the heavier elements that you're ultimately going to need to eventually get to us. Because you need that carbon, you need the things that are necessary. You need iron, you need carbon, you need all of these heavier elements to support life down the road. And so we see as this process of stars being born and stars dying, that it brings it down to us. Now, I want you to think about that process for just a minute, because again, we're starting to see something that seems very unlikely. And remember, in the last episode, we showed that example of Stephen Hawking's using the ball bearings and talked about how remarkably unlikely that would be, that gravity would be able to stop all of that material from the Big Bang from just spreading out into space and being gone. But somehow gravity manages to do it. Now, does that on its own raise to the level of being a deal breaker or a miracle on its own? No, it doesn't. There are plenty of theories out there of how that might have happened. Again, remarkably unlikely. But that's our first unlikely step, is that the first generation of stars forms. Our second unlikely step, they go through that process that Hoyle identified to produce the heavy metals needed inside the stars, and the stars die just right to produce the material that we're going to ultimately need for us. Now that's going to bring us to the doorstep of the Milky Way. And what we're going to find is that our galaxy is rather remarkable, and our place in it is rather extraordinary, and the journey of how we got here, and it is a journey. So we're going to talk about that a little bit this week, kind of setting up next week's episode. But I want to kind of kick this off, and I want to point to this picture that just popped up here over my left shoulder. This is what we're looking at with the Milky Way Galaxy, and this is a good representation of what the Milky Way Galaxy looks like. We're going to find that we need that bright and shining center of the galaxy, that place there in the middle where you see where everything comes together. I'm always reminded of the line from Star Wars where C-3PO asked Luke where they're at when they first meet, and Luke said, well, if there's a shining center to the universe, you're on the planet that it's farthest from. And of course that was Tatooine. But that bright and shining center of the galaxy in this case, that's going to serve an interesting role as we go forward. That's where all the goodies are made that we need to produce us. All of those heavy elements that we need are going to be made in that bright and shining center of the galaxy. But there's a problem, and the problem is radiation. So inside that bright and shining center of the galaxy, it's bright and shiny for all the wrong reasons. You've got supernovas, you've got all sorts of stars, you've got all sorts of things that are not going to be friendly to life. But you've got the elements that you need to produce life. And this is going to be the conundrum going forward. So I want to go ahead and put this quote out there. Again, this is from a book called The Privileged Planet with Dr. Gonzalez and Richards. And I want to talk about this for a minute and kind of walk through this idea of what we're getting here and what we need from that bright and shining center of the galaxy. It says, all galaxies in the early history of the universe and low mass galaxies forming right now are metal poor, making them unlikely habitats for life. So they don't have those heavy elements that we need. Similar problems attach to globular clusters and irregular galaxies. We now have reason to suppose that large spiral galaxies like the Milky Way that formed at about the same time are substantially more habitable than galaxies of different ages and types. The metal content of a galaxy is highly dependent not just on its age, but also on its mass. Without enough metals, there aren't enough materials for building terrestrial planets. And without terrestrial planets, there are no environments suitable for life. Our very massive spiral galaxy, then, is an especially suitable home for a habitable planet and solar system, while providing an optimal position for viewing and discovering both our own galaxy and the wider universe. I want to put that out there as our food for thought for next week's episode. And what I want you to consider as we jump into this next episode is, that was a very long list of things that are going to have to be just right as we look at our galaxy. Again, we're going to find that the Milky Way is that Goldilocks galaxy. So we've moved kind of quickly through how we got from the beginning of the universe to the Milky Way. But we're going to camp out here next week on this idea of the Milky Way Galaxy and look at, well, how special is the Milky Way Galaxy? Is there anything that's unique? Is there anything that unique about it? And what about that bright and shining center of the galaxy? How do you get what you need out of the middle of it, but you don't park there so that you get irradiated by it? And it seems like that's going to be problematic. We're going to talk about all of that on the next episode. I hope you enjoyed this episode. What we're trying to do is to lay the foundation of where we're going. So this week we were a little more conceptual. Next week we're going to talk a lot more about the specifics of moving through the Milky Way Galaxy. What makes it special? Or is it just an ordinary routine galaxy? What do we need from the Milky Way Galaxy to produce life, to get to us, if it all just happened by chance? And that is what we're going to look at next time. Thank you so much for joining us. If you've got questions, you can reach out to us at prooftograce@yahoo.com. You can also find us on our website at prooftograce.com, and you can find our podcasts here on YouTube, Spotify, or iTunes. Thank you so much for joining us, and I look forward to seeing you next time. Bye-bye.